Hello and welcome to our virtual classes devoted to block number 3. And I tried to make these virtual classes in the same way as we have the usual ones. First of all, there will be 3 videos which will mimic the lecture we usually have at the beginning of our classes. And then I have also 3 videos which will actually devoted to the exercises that we usually have on seminars. Okay, so I'll start with this lecture where I'm going to sort of give you an overview in a similar way like I did before. I will take a particular case and show you how to solve this case using the methods we discussed in block number 3. Okay, and this is actually the case. You can see a screenshot from EDA Lohnstatistik. If you don't know the EDA, it's Engineering Society of Denmark, and they actually collect information about salaries of engineers every year, and then they combine all this information into a big document which is called Lohnstatistik. What you see on this screenshot is actually a salary of engineers, civil engineers, depending on the seniority. So it means that it depends on the years they graduated. For example, you can see that if they graduated in 2019, the average salary is about 39,000. It's a gross, it means before taxes. And then this is the amount of persons, the amount of engineers who actually gave an answer. You can also see some statistics, the quartiles, the 90th percentile, and so on. So the idea is following. Let's see how average salary of engineers depends on the seniority. And then I'm going to use not the real years, I will use the seniority years. For example, 0 means they just graduated, 1 means they graduated 1 year ago, and so on and so forth. So I will simply take these numbers for the last 10 years, and then I will use it to make this analysis. Okay. So you can see that I'm going to use Excel for this exercise just because it will make a lot of calculations easier. Usually I use a blackboard, but in this case I will use Excel. Okay. I will also draw some formulas and some other text here. So I'll just remove this screenshot. So what you see here is my X and Y data. X is how many years actually passed from the graduation. And you can see I don't have 0, I have only 1. It means 2018, 2019, and so on. So you can see that up to 10 years. And this is the average salary in thousands of Danish krona in a month, right? So for example, this means 40.7 thousand a month. Okay, and then if you look at this data, so this will be my X, it's the seniority, and this is Y, it's the salary. So I'm going to investigate the relationship, the association between X and Y using the methods that we already discussed in the theoretical lectures. Okay. So since we have only 2 variables, X and Y, I'm going to use all the methods that actually devoted to investigation of relationship for the pair of variables, meaning I will try to calculate covariance, correlation, confidence interval for the correlation. I'll make a simple linear regression and so on. So actually most of the methods that you are going to use for solving problem 1 in mini project. Okay. Okay, let's start. First of all, of course, I need to calculate an average, and actually, first of all, I need to calculate the sum, right? So I need to calculate sum of all X variables and then sum of all Y variables, and then sums will be sort of very important in this case because you know that most of the statistics we are going to use, they actually based on these sums, right? So this is a sum. So, and then you know that every sum has, now you know this, every sum has its own like a letter or several letters, and then for example the sum of X values, usually we use S and then the X, right? So this is a sum of X values and this is a sum of Y values. Okay, now we can calculate means. In this case you just simply take the sum and divide to the number of values. In this case I just use 10 here. So this is MX, this is mean X, I'll just make it bold, and then this is the I do the same. I take a sum and divide to the number of values. So this is average salary for all. So this is average salary for all years, right? So for all 10 years. Okay, this is it. Yeah. Now, the next step, I need to calculate how far every value from x and every value from y is from the mean, right? So I just need to calculate this distance between x and average x. So I simply say 1 equal 1 minus and then average value, right? I use dollars to fix it. And then I simply do it like this, right? So you can see, for example, 1 is by minus 4.5 smaller than the average, and then you can see 10 is by 4.5 larger than the average, and then you can see, for example, 6 is by 0.5 and so on. We have 5 values that are negative on one side, 5 values that are positive. Okay. Now I do the same for the y values, y minus my minus my, and then I do the same thing, right? So I say this is minus average value. So I simply calculate how far every value in my sample is from the average, right? So you can see that if you take an average, then you can see that if you're just graduated a year ago, you will have by 9,000 a month smaller. And then if you graduated like, comparing to average, of course, and then if you graduated like 10 years ago, you will have by 8,000 larger. So you can see the difference is 17,000. That's a lot, right? For 1 year. And then you can see actually on year number 5, you have exactly the average salary within a certain decimals, of course, right? So that's it. And then the next step is to calculate the same but squared. So I say x minus mx squared. I'll just use it like this and then do it as a superscript. And then, oops, not this one, but only this one. Superscript, yes. And then the idea is very simple. We just take this one, say equal to this one, and then square it, right? So this is the squared distance between the values and the average. And then I do the same here. And just copy and paste and add that this is squared. Superscript. Here we go. And then I say it's this value squared. This is, you already know very well, because this is what you actually used also in block number 1 to calculate the variance, right? And that's what I'm going to do as well. So I simply calculate a sum, another sum. I say take a sum of all these squared distances, yeah. And then you know that this sum is called SSXX, meaning SS means sum of squared values, and XX, it means it's not just sum of squared x values, it's x minus mx, right? So this is the sum of centered x values, sum of squared centered x values. And then I do the same here. I take a sum of this, and this is what gives me SSYY, right? And now I can calculate what is called a variance. It's simply the it's average of this, but of course we lost 1 degree of freedom, so it means that we have to divide to n minus 1. So I say the variance of x, I'll use this without superscript just to save time. It's simply this value divided to 9, right? So n minus 1, and then I will use the same number, let's say 2 decimals here, and then the same here. So this is the variance for y, and this is also, I take this one and divide to n minus 1, right? So this is my values, right? So this is what you already know very well, right? Now I'll just remind you quickly the basic formulas that we use. So you know that the sum of x values, it's simply when you sum of x values, yeah, and then the sum of squared x values is when you take a sum of squared x values, and then this sum, SSXX, it means that you take a sum, not just squared x values, but x minus mx squared, right? So that's the difference. And then for y, you just simply substitute x to y, right? So this is what we have done right now. Now, the next step is to calculate covariance. And for covariance, we need to calculate this sum, right? So SSXY, which means that you take a sum of x minus mx, and then you multiply to y minus my, right? So you simply want to look at how big the difference between x and average x for this particular value, and then how big the difference between y and average y for this particular value. Is it below average or it's above average? And then you multiply it together, right? So let's do that. I will just make it a separate column here. Just say x minus mx, x minus mx. then y minus my. Then I simply do the calculations. This is my x minus mx multiplied to y minus my, right? And then look, you can see that if you have a negative value here, it's a big negative value, the largest one, but it's also the largest negative value here. So the result is positive, right? Then if you look at this, you can see that when this is negative for x, this is negative for y. And when this is positive for x, this is positive for y. So you can see that even if we didn't make a plot, which is always a good idea, you can see that we have a very good covariance between x and y already just by looking at the numbers, right? And therefore, when I calculate this, you can see that all these values, of course, the magnitude is different, but all these values are pretty big. So it means that if I calculate a sum, so this SSXY, this is my sum, I will get a very big positive number. So this is SSXY. This is what we call SSXY. And now I can calculate the covariance, right? So the covariance is simply the sum divided again to n minus 1, which is 9 in our case. So this is the covariance. I will write covariance here, and then I'll make a number of decimals also equal to 2, for example. Okay. So this is the covariance. Now, these are statistics. These are main statistics that we just calculated. And this is what we are going to use for the further calculations, for calculations of regression and the correlation, right?